All right, let's dive into a journey that pretty much every successful developer goes on. It starts with the absolute thrill of having a hit app, and then the total panic when that app just won't stop crashing. Let's get into it.
So picture this. You've done it. You've built something great, you've launched it, and well, people are actually using it. The code is solid, the features are spot on, everything is going just the way you imagined.
Actually, scratch that. It's going way better than you imagined. Users are pouring in. They love it. They're telling their friends, and your user count is just going up and up and up. I mean, this is the dream, right? Well, the dream's about to feel a little more like a nightmare, because right when you're at peak traffic, the app starts to lag. It gets unresponsive, and then, poof, it just crashes. You scramble to restart it, it works for a bit, but the problem always comes back. So what is going on here? Here's the thing. This isn't really a story about failure. It's actually a story about the problems that come with success. Your code isn't bad. Your setup is just, well, you've outgrown it. At the heart of it all is this simple fact. Your app is probably running on a single server. And you can think of that server like a single-lane highway. During rush hour, it doesn't matter how great the cars are, that one lane is going to get backed up, and everything will grind to a halt. You've hit a bottleneck caused by your own success. So you can't just hope for fewer users. That's not a solution. What you need to do is build more lanes for your digital highway. And, just as important, you need a smart way to direct all that traffic. And that's where the load balancer comes in. You can think of it as a super smart traffic cop for your application. Instead of all your users trying to jam onto one server, the load balancer stands at the front gate and directs each car, each request, to one of the many servers you now have running. It just spreads the load out. And this diagram shows it perfectly. Look, on the left, you've got all the user traffic coming in from the internet. In the middle, you have a tool like Nginx, which is our traffic cop. It's the single front door, and it takes all those incoming requests and intelligently sends them to your server farm on the right, which now has multiple copies of your app running. This is what people mean when they say scaling horizontally. You're not making one server bigger, you're just adding more servers. And Nginx is really clever about this. It's not just random. It can use a round-robin method, which is super simple. It just goes down the list. Server 1, server 2, server 3, and then starts over. Or it can use least connections, which is a bit smarter. It sends the new request to whichever server is the least busy at that exact moment. Then there is IP hash, which is crucial for things like a shopping cart. It makes sure that once a user is connected to a server, they stay on that server so they don't lose their cart contents halfway through shopping. Okay, great. Your app isn't crashing from too much traffic anymore. You've got multiple servers running smoothly. But, this solution creates a totally new problem. When your app is running in a bunch of different places at once, how in the world do you know what's actually happening inside? I mean, seriously, think about it. With everything distributed across all these machines, how can you possibly tell what's going on in each one? If one of them starts acting weird, how would you even know which one it is? Your whole system has basically become a big black box. This is exactly the problem that Prometheus was built to solve. Prometheus is this amazing open source tool, and its entire job is to reach into all of your application instances, collect vital signs, metrics, and store them as time series data. That way you can see not just how things are now, but how they've been changing over time. And the way it works is surprisingly simple. First, you instrument your app, which is a fancy way of saying you add a small library to your code. This library then exposes a special web page or endpoint, usually at /metrics, that just lists all the health data. Then Prometheus comes along and scrapes that page every few seconds, grabbing all the latest numbers and then storing them. It's a really simple, pull-based model, and it's incredibly powerful. So what should you even be looking at? A really fantastic, simple framework is the RED method. It's all about what your users actually care about. R is for rate. How many requests are you getting per second? E is for errors. How many of those requests are failing? And D is for duration. How long are people waiting for a response? What's your latency? If you just monitor these three things, you have a really, really good idea of your user's experience. But the RED method mostly tracks problems that your users see right away. Some of the nastiest problems are way more subtle. They're not a sudden spike in errors. They're the slow, silent killers that can bring down your whole system without any warning. Yeah, I'm talking about memory leaks. A memory leak in Node.js is basically a chunk of memory that your app used for something, but then it forgot to clean up after itself and give it back. Think of it like a very slow, silent flood. These little forgotten blocks of memory just start to pile up, consuming more and more RAM until eventually there's none left and the app just dies.
To really get this, let's do a quick look at memory. You've got the stack, which is for simple, static data. It's fast, and the OS manages it for you. Easy. Then you have the heap. This is where all the dynamic stuff lives. Objects, arrays, you name it. It's also where the garbage collector does its work. The garbage collector's job is to find objects that aren't being used anymore and clean them up. But sometimes it gets tricked and it fails to release memory it should have. And that's exactly where a memory leak happens, right there on the heap.
And this quote from a developer on Stack Overflow just captures the whole challenge perfectly. Look, a healthy app's memory goes up and down, right? The garbage collector runs and memory usage drops. A memory leak is different. It's that slow, steady, relentless climb that never goes back down. The goal isn't just to see memory usage. It's to spot that dangerous upward trend long before it's too late. So now we have all this amazing data pouring in from Prometheus. We've got request rates, error counts, detailed memory usage, but let's be honest, a screen full of raw numbers is not going to help you when things are on fire at 2 a.m. You've got to be able to see the story in the data. And that's where Grafana comes into the picture. You can think of Grafana as the mission control for your entire system. It plugs right into Prometheus and transforms all that raw time series data into beautiful, easy-to-understand dashboards. It turns a fire hose of numbers into a story you can actually read. But, and this is a big but, not all dashboards are created equal. A low-maturity dashboard is usually just a jumble of graphs someone copied from the internet. It's cluttered, it's confusing. A high-maturity dashboard, though, is designed with a purpose. It tells a specific story. It reduces the amount you have to think, guiding your eyes to what's important. It's consistent, it's interactive, and it's tied to alerts. It doesn't just show you data. It helps you find answers. And that brings us all the way back to the beginning. When we put all of these tools together, we can finally transform that fragile, crashing app into something that's genuinely robust and resilient. So let's just recap the whole toolkit. Nginx is our gatekeeper. It directs the flow of traffic, making sure we can scale. Prometheus is our detective. It's on the inside, capturing all the critical data. And Grafana is our storyteller, visualizing that data so we can understand the health of our application with just a single glance. And that leaves us with one final, really important question to ask yourself about your own work. Is your application just running, or is it truly resilient? Because an app that's just running can fall over at any moment. But a resilient application, one that's scalable, observable, and understandable, that's an app that's built to last. So, which one are you building?